Diagnosing the motorhome charging system is no more difficult than on any other motor vehicle, provided you understand how it's put together and operates. While the charging system essentially relates to the 12-volt systems for the chassis and living area, there also are tie-ins to the 120-volt system. In this film, we will explain the charging systems on both 1975 models and on earlier models, and we will explain simple tests used to isolate problems in them. First, let's quickly review the charging system components and what they do. The Delcatron provides 12-volt DC charging current whenever the engine is running. The power converter supplies a slow charging voltage whenever it's plugged into a good 120-volt source. Depending on the year of the motorhome, there will be either 2 or 3 batteries. For 1975s and 1976s, there's an automotive battery up front rated at 3,350 watts, and a heavy-duty battery rated at 4,500 watts in the motor generator compartment for the living area and for cranking the motor generator. We'll call this the living area battery. On earlier vehicles, there are automotive and living area batteries up front. If the motorhome is equipped with a motor generator, there is a third cranking battery in the rear. A diode assembly, 2 diodes mounted in a heat sink, is installed on the firewall. It allows the generator to charge both batteries, but keeps their circuits separate so that one can't drain the other. A magnetic switch, controlled by the battery boost switch, can connect the 2 batteries in parallel. On the 1975 system, a second magnetic switch shunts the circuit breaker when the batteries are in parallel. This mag switch is in the motor generator compartment. Those are the basic components. Now let's tie them together on the wiring diagram to understand exactly how the system works. We'll describe the 1975 system in detail and then explain the differences in earlier models. The output of the generator is tied to the diode assembly and has 2 outlets from the diode assembly. Following the right-hand path on the diagram, we see that the generator output feeds the junction block to supply the electrical needs of the chassis and also can charge the vehicle automotive battery. This is the same for all model years. Following the other path from the diode assembly, the generator output goes to the living area battery junction block through a 0-gauge cable, which continues to the motor generator compartment. The living area battery is charged through this cable and the master circuit breaker. The generator also supplies power to the fuse block for the living area 12-volt system. The power converter also is connected into this living area battery junction block, and it supplies the living area fuse block and charges the living area battery when it is connected into an external 120-volt power source or the optional motor generator. To provide cranking power for the motor generator, another cable goes from the living area battery positive terminal to the motor generator. As we've described the system so far, the living area battery and its circuits are isolated from the vehicle battery and its circuits by the diode assembly whenever the vehicle generator is not supplying power, that is, when the engine is not in operation. A diode, as you probably know, is a one-way electric check valve. The diodes can provide isolation of these circuits so that the vehicle battery is not discharged by a living area load or the living area battery discharged by a vehicle chassis load when the engine is not in operation. To provide additional battery power, there is the battery selector switch. In battery normal, the circuits stay isolated. In battery boost, they are tied in parallel. When the battery selector switch is in boost, it energizes the magnetic switch. The 2 batteries are then in parallel, and several things can happen. First, the power converter can charge the automotive battery as well as the living area battery. The living area battery can supply power to crank the motorhome engine if the automotive battery is low, or the automotive battery can crank the motor generator if the living area battery is low. That's why we have these heavy cables to tie the automotive and living area batteries together in battery boost. The rear magnetic switch that you see here shunts the circuit breaker when the battery selector switch is on boost. This is because it takes about 60 amps to operate the starter, and the circuit breaker would try to break the circuit during cranking. So, with the living area battery at the rear in 1975 models, the circuit has two mag switches, and both are energized when the battery selector switch is on boost. The switch, in turn, will energize either battery. Now, let's look at how the 1974 and earlier system differs from 1975. The chassis portion, as mentioned earlier, is identical to the 1975 system. The cabling for the living area circuits is connected to the diode assembly and through the master circuit breaker to the living area fuse panel. The generator charges these two batteries. The power converter ties directly to the fuse block to charge the living area battery, and it will also charge the automotive battery when the bat boost switch is operated. The motor generator, with its own battery, is entirely separate on the early model motorhome and provides its own charging circuit for the battery. But on some motorhomes, a third wire modification ties the motor generator battery in parallel with the living area battery, so that it can be charged from the power converter or automotive generator. This arrangement is described in Service Bulletin 73-1M12. Now, a minute of explanation about the battery selector switch and some significant changes from 1974 to 1975. In the normal position, they're all the same. The mag switch or switches are de-energized and the batteries are isolated. On 1974 and earlier vehicles, the selector switch will stay in whichever position you leave it. Leave it in boost, and the converter will slowly charge both batteries. However, it should be switched to normal with the converter off. The energized mag switch pulls a small amount of current, and if the owner leaves the vehicle parked in battery boost, the switch current will drain both batteries. Also, the selector switch is powered only from the automotive battery on early models. If the automotive battery is dead, switching it to boost won't energize the mag switch solenoid to tie the batteries together from the living area battery. So here's a tip. If the living area battery is up and the automotive battery is dead, you can bypass the selector switch circuit. Run a jumper temporarily across the mag switch from the engine battery side to the living area battery side to get power to start the engine. On 1975 motorhomes, the battery selector switch is powered from either the chassis or rear battery. So if either battery is up, the mag switches will connect the circuits together. However, the 1975 switch is only momentary in battery boost to prevent accidental battery draining. The circuits are tied together only while holding the switch in. If you want to charge the automotive battery from the power converter, you can do it by connecting both battery wires at one terminal on the front mag switch. So that's the operation of the charging systems. When you approach diagnosis, be sure to refer to the wiring diagram to refresh your memory and locate test points. Now let's discuss diagnosis of the system in this order: the batteries, the power converter, the dual diode isolator, and the generator. First, on problems of the battery draining, be sure to check the condition of the battery, its electrolyte level and specific gravity. Remember that a battery with a dead cell won't hold a charge. If the water continuously boils away, it means the automotive generator is probably overcharging and should be checked out, as we'll describe later. Is the battery case dirty? This can cause current to drain off. See if you can read a voltage difference between the positive terminal and the case. If so, cleaning it up could correct the problem. Where both batteries are draining, find out if there is power with the selector switch in the bat boost position with the power converter off and the engine running. If the problem seems to be that the power converter isn't charging the living area battery, there's a simple voltage output test to check it, and voltage drop test to check the wiring. The converter has a built-in voltage regulator in its power transformer that will maintain about a 12-volt output under load or 14 volts no load. With the living area battery charged and all the 12-volt circuits off, measure the voltage at the converter out lead to the battery junction block on 1975 or the fuse block on earlier models. It should be about 14 volts. Then turn on a few lights or the water pump so that the circuit is loaded. The voltage output should remain at least 12 volts. Leave the lead on and test for the same voltage under load at the living area battery terminal. If there is a significant voltage drop, say 1 volt or more, from the converter to the battery, you've got a bad connection, and further voltage drop testing should pinpoint where it is. Now, if you don't get full voltage output from the converter, check the power in before you decide you've got a bad converter. Remember that it has to plug into the 120-volt system or motor generator. Remember that the 120-volt system gets its power through the external power cord when it's connected to either the motor generator or the campsite power supply. What kind of problems can this give us? First, most campsites don't have the right power supply, and we come in with one 120-volt circuit to feed both master breakers. Then, with air conditioning and a few other appliances turned on, we're calling for more current than the source can supply. So make it a rule to test for a full 120 volts AC available to the power converter. Or if the power source is questionable, test the converter output with all other 120-volt equipment turned off. If the problem seems to be no charging when the converter is being fed from the motor generator, the generator output may not be right. To test the motor generator output, first disconnect all 120-volt sources. Plug a frequency meter into the outlet. If the motor generator doesn't put out 63 cycles at no load, it needs maintenance. So refer to your GMC Motorhome service manual. If you have good power into the converter, but the output voltage isn't up to specifications, replace the converter. The diode assembly should be tested if it appears that the automotive generator is charging one battery and not the other. The simplest way to test it is to compare the generator out voltage with the diode out voltage. With the engine at fast idle, 1,000 to 1,500 RPM, and all circuits turned off, ground the voltmeter negative lead and touch the positive to the generator terminal on the diode assembly. Record the voltage, which should be from 13.5 to 15 volts. Then, move the voltmeter probe to each of the battery terminals in turn. They should be between 1/3 and 1/2 volt of the first reading. If not, replace the diode assembly. Now, if the diode assembly has failed, here's a temporary fix. Run a jumper wire from the generator terminal to the output terminal of the open diode. But remember, this will allow the battery it charges to be discharged by the other system. Here's something to be careful of when testing the diode. Be sure all the 12-volt circuits in the motorhome are off. If the diode on the chassis side is open, the voltage surge when the engine starts could put out everything turned on. The vehicle generator regulator should be tested in case of severe gassing or water loss indicating an overcharge, or where neither battery seems to be charging adequately. This generator has an integral voltage regulator that maintains the generator output voltage. For low or no charging, you should perform a generator output test using a voltmeter, ammeter, and carbon pile as described in your GMC Motorhome maintenance manual. If the output is controlled and within 10% of rated output in the specifications, the generator is okay. If output is low, remove the generator for bench testing. A new item of test equipment for checking the generator internal regulator is this SI charging system diagnostic tester tool J26290. Use it if the voltage is unregulated or if the generator is overcharging. It's simple to use and the instructions are on the tester. With the engine off, plug the generator connector into the tester and plug the tester leads into the generator. Ground the tester on the generator frame. If the tester light comes on and remains on, it indicates that the tester itself is faulty. If the tester light remains off, pull the tester connector plug from the generator. If the tester light then flashes, you should replace the rectifier bridge. If the tester light remains off, either the tester is faulty or no voltage is getting to the tester, probably because of a broken or faulty connection. If the tester light flashes with both sets of leads connected, you should start the motorhome and bring the engine to fast idle. With the engine at 1,000 RPM or more, if the tester light remains off, you can conclude that the generator system is okay. However, if the tester light remains on with the engine at fast idle, you should remove the generator for bench testing. If the tester flashes, you should remove the generator and check the regulator, rotor field coil, brushes, and slip rings. Finally, let's talk about an electrical supply condition that is not a problem: a growling sound in the refrigerator electrical circuit on 1975 motorhomes. The electrical refrigerator is a 120-volt AC, 12-volt DC unit with an inverter built in to change the AC or DC supply to 23 volts AC to run the compressor. On past models, it was wired for a 12-volt DC input only from the battery or power converter. In 1975 motorhomes, we've added a switching circuit so that when 120-volt power is coming to the motorhome, it will automatically switch the refrigerator so that it will run off of the 120-volt power. The switching device is a relay built into the inverter assembly, and it makes a growling noise when switching from 12 to 120 volts when you start the motor generator or plug in at the campsite, or going back to 12 volts when the 120 is unplugged. This is normal and should not be considered a problem. So you see, it is not difficult to test and diagnose the motorhome charging system, provided you understand the circuit, how the different electrical systems relate to it, and a few simple electrical test procedures. Refer to your maintenance manual for the necessary wiring schematics and correct service procedures and specifications for surefire diagnosis of the motorhome charging system.